All right, here we go. Here's the solution. Y is equal to g 0.5 times x. So our b value is 0.5. Now, if you think about the original points, x comma y, the image, if the b is 0.5, the x get multiplied by the reciprocal of it. So this is what this blue text is talking about. If the original is x comma y, the x values get multiplied by the reciprocal of that. So what is the reciprocal of 0.5? 1 over 0.5, or easier to think, the reciprocal of a half is 2. So if you think of 0.5 as a 1 over 2, the reciprocal of that is just 2. So that's why your x values are getting multiplied by 2. And you see that pattern in this table of values right here. -3 becomes -6, -1 becomes -2, okay? So you're getting here, I'll just write on it just to reinforce it. We'll get the click sound, I was hoping. So here we get, we get a -3, there, finally. There we go. We get this -3 is going to get multiplied, so multiplied by times 1 over b. Okay, so -3 times the reciprocal of a half. So the reciprocal of a half is times 2. So that's why we get -3 turns into a 6, because the reciprocal of a half is reciprocal of that is 2. All right, now let's go on to our next page. First of all, the good news is that you've really learned all the stuff that's in this entire chapter. But kind of like learning, I don't know, remember if you took piano, and first of all you have to learn the left hand, and then you have to learn the right hand separately, or whatever order. You probably learn the right hand first, and then afterwards you'd put the two hands together. That's what we're going to do. We're going to be combining all these different things. So just in today's lesson alone, we've learned about using A and B, so we're going to combine them together. So here, if you're going to combine the vertical and the horizontal, if you're starting with x comma y, and now if we have an A and a B, so if A doesn't have to be 1, it can be anything, and B doesn't have to be 1, it can be anything. So here's what happens. Your x value gets multiplied by the reciprocal of B. So if I say the original is f of x, right, y is equal to f of x, and now our image is y is equal to A times f of x, or f of b times x. Any point x comma y on my first graph, on my first function, will be the corresponding point will be, now remember, this b is associated with the x. It's easy to see, except it's the reciprocal function. So this x will be x over b, okay? Or another way to think of it, x is multiplied by the reciprocal of b, okay? So in our previous example, b was 0.5, so it'll get multiplied by 2. Comma, now my y value, it's kind of easier, just gets multiplied by a, so you get a times y. So on the original graph, x comma y, the corresponding point would be x over b comma ay. So here's an example. This is the original graph, y is equal to h of x, okay? And now you are supposed to graph this one. So if we take this apart, you can say, okay, a is equal to -1/2, and b is equal to 2. Okay, so my a is associated with my y values. My y values are going to get multiplied by 1/2. So we can pick a bunch of points and multiply every one of my y values by -1/2. My b, it's tucked inside there right beside the x. It's associated with x, but it has that reciprocal nature to it. So all my x values of the original function are going to get multiplied by the reciprocal of 2. The reciprocal of 2 is 1/2. So if I scroll down a little bit, here's their table of values. So your x and your y, you notice that happens just like that. -2, my x value gets multiplied by the reciprocal of 2. So Oh, there we go. This is the way they wrote it here. So the x values get multiplied by the reciprocal of 2, so that's the same thing as dividing by 2, so that becomes -1. My y values get multiplied by -1/2, so 12 becomes -6, and so on all the way through. So if we take a look at this, it's really kind of hard to understand, but we can kind of piece it together. This negative here means that my y values are getting multiplied by negative, so I'm going to have a reflection across the x-axis. So perhaps the first thing you can think of, here's my original function, goes like that. So then I've got a reflection of it. So that's why instead of coming from the top downwards, this is why it's got reflected. So it's got this shape to it. And then it's a little bit hard to make too much sense of it. But my y values are be multiplied by something between the absolute value of 0 and 1. So I've got a vertical compression. So you can imagine if you put your one hand here and one hand there, and you sort of compress it, push the graph paper in. So this does look a bit compressed. And then my x values here, they're going to get multiplied by the reciprocal, 1/2, so it's another compression. So if you kind of grab the paper here and you push it in, you've got a compression that way as well. So it gets a lot more compact, and you see from the original shape it gets reflected and it's compressed in both dimensions. So really what it boils down to is picking a bunch of points, and pick convenient points where you know where these lines are crossing, right? So you see the original. So this one here is the -2, 12. So this is, if I was to label them, right, that's their A point. So pick convenient ones that are fairly straightforward to figure out, right? And then this A is going to turn into -1, -6. So -1, -6. So this would be A prime, okay? In the same way. That's the corresponding point. And then B prime, -1, 2 turns into -1/2, -1. So this one over here would be B prime. Okay, so follows in that order. Did I do that right? I think so. -1. Yeah, I think so. All right, so let's take a look then at the other example here to check your understanding. Instead of making you do it, let's just take a look at it. So the A value is 4. And the B value is -0.5. So remember, this multiplies your y values by 4. This multiplies your x values by the reciprocal of it. Okay, so here's some original points that they picked. -2, -2, 0. That's the first one. So if I was to make this one A, right there. So my y values get multiplied by 4. 0 times 4 is still 0. My x values get multiplied by the reciprocal of that. So the reciprocal of -1/2 is -2. So all my x values get multiplied by -2. So this would be A prime. So if I was to find that point, it would be 4, 0. So this is the first point. -1, 1 is right there. And again, we'll take a look at it. My y values get multiplied by 4, so 1 becomes 4. My x values get multiplied by the reciprocal of that, so they get multiplied by -2, so that becomes 2, 4. So 2, 4 is way up over here. So we're going to get a weird kind of a shape here, and it's going to be taken off right away. 4, 0. 2, 4, and then -4, 8. -4, 8 was way up over there. So you can see this shape ends up getting kind of bent that way. All right, I doubt that they make a graph for us, unfortunately. No, they don't. All right, let's take a look at the next page here. And we'll okay, so write an equation of the image graph after transformation. So now, instead of the table of values, they want us to make an equation of it. So here we have the graphs of y is equal to f of x and its image after a vertical and a horizontal stretch are shown. Write an equation of the image graph in terms of function f. All right, so identify corresponding points on y equals f of x and its image. Oh, you know what, I'm just going to try to do a pause here. Okay, I just wanted to take a look at this. It's a little bit hard to read which is the original and which is the new function. So this one here is the original function, and then I think it comes up this way. All right, and then how about I'll try to color on top of the new function. So the new function is coming over here in blue. And so that's our new function, the image function. Okay, so now I've used my blue, I've got to start with something. All right, so we need to find a couple corresponding points. Well, you'll notice that my original function, the non-blue one, the black one, goes up here and it goes down here. So there hasn't been really a reflection that's taking place here, right? So I think that, what do they use? They use this one here, which looks to me, oh no, I think they use this one here. Let's erase that previous little bit there. Okay, so can I? Yeah, I kind of do. All right, so this is that maximum, and it lines up with this maximum. Okay, so this one would be negative 2, comma 4. That's this point here, negative 2, comma 4 on my original, and this one is negative 8, comma 12. Okay, now I'm not really a big fan of how they do the explanation here. How about I'm going to use this white space over here, so let's just forget about this for a second. I'm just going to explain this over here. So I think if we keep track in 2 columns and we keep separate the original function over here, oh, back to blue. So if we have one column, say, for the original function, and then another one for the image. So our original function is defined. They tell us it's just your straight ahead y is equal to f of x. And our task in this one is to find out what the a and the b values are. So our generic is y is equal to a f of bx. And really what we want to do is, what are A, what is B? We're going to try to find that out. So the first thing we say, okay, we got these corresponding points. This negative 2, comma 4 goes with our original one, right? That's the original one, so we'll go negative 2, comma 4 is a point on my original function, and the corresponding is negative 8, comma 12. All right, so the generic, what is negative 2, comma 4? This is an example of x, comma y. So this would be, like in my table of values, clearly this is an x and this is a y. Well, how does that work again? My x, if you recall, my x gets divided by b, right? So the corresponding point for x, over here, would be x divided by b, comma, my corresponding point for the y, remember that gets multiplied by a, so this would be ay. Okay, so we're almost there, and I kind of like to think this through a little bit logically. So let's just look at the x values first. Like I'll say, okay, so when x is equal to 2, oh, sorry, negative 2, when x is equal to negative 2, then this x over b is equal to negative 8, right? So now, like this x is the same as that x, so that's I can substitute, I can look at x over b equals negative 8 and just substitute a negative 2. So I'll say negative 2 divided by b is equal to negative 8. Okay, I am running out of room here, so I will multiply both sides by b. So when I multiply both sides by b, I get a b on this side, and that one cancels out. And then I have to divide both sides by negative 8, so I get a b is equal to negative 2 divided by negative 8, so that's a positive 1/4. Cool, I'm half done, right? So I got my b value, so I know what this one is. Now I just want to figure out what my a value is. Well, maybe I'll switch to green over here. So I'll do a similar statement. So instead of when x is equal to negative 2, now I'm going to say when y is equal to 4, and then over here ay is equal to 12, right? So what will y be equal to? So what times 4 is equal to 12? Or if I make it more formal, I can write like a, just like I did before, a times 4 equals 12. And so therefore my a is equal to 3. Okay, so here I get the same answers that they did. The b is equal to 1/4 and a is equal to 3. Works out fairly well. They then do a check, right, with another set of values. So I think that they pick, I'll go with red on this one. So I think they pick a 1,4. They pick this one on the original, which corresponds to this one way over here. Let's see if it works out. So I'll just cheat and, well, if we did our same piece over here, maybe I'll write it up on top just because I'm running out of room. Okay, so now I've got to keep track of these. 1,4 is my original. So I have it in my original column. And then the other one, that is the 4,12. That's on the image side, right? So same idea, I'll even write this on top. This is x comma y, and this is x over b comma ay. And hopefully what we're doing is we're checking out the situation. Is it true that a is equal to 3 and b is equal to 1/4? Well, why don't we check out the a first? So that the a involves the y value. So the question is, if y is equal to 4, right, and ay equal to 12. If, what was our a value again? If a is equal to 3. Okay, so 3 times 4 equals 12. Yes, it worked. All right, so we checked out, our a value works good. So what if we checked out our b value? That has to do with the x. So if x is equal to 1, x over b is equal to 4. See how I'm associating those together? So x is 1, so 1 divided by 1/4. Oh, now I'm just getting this tricky stuff here. Let me just flip over here. So 1 divided by 1/4 is equal to 4 here. Now, for some of you guys, you can think, oh yeah, this is so easy. Other people, there's a complex fraction here. So we're going to be dealing with complex fractions later on in our course. So here's one little piece that will always unlock these things. Here we are dividing by a fraction. So if you say division is the same thing as multiplying by the reciprocal. So instead of 1 divided by 1/4, I can say 1 times the reciprocal of 1/4. So what's the reciprocal of 1/4? It's 4 over 1. Right? And that is pretty easy to see is the same thing as 1 times 4 is 4, so we're good. So that confirms that our b value was right. So which tells us, yay, our b value is 1/4, so we get it right. Okay, so that was a mouthful. And now I would like you to try number 4 over there, and they even give you a clue when they give you some corresponding points. So I would take this minimum here, and that minimum is a nice one, and then you got this point and that point. See if you can figure out what your a and your b is. So instead of stopping it all together and then restarting it, I'm just going to say try it on your own and then come back. I'm just going to do like about 5 seconds of silence here so that you can pause it. Okay, I hope you have done that one. I'm just going to click on our Show Solutions. And coming up in blue, so they tell us that the correct answer is you get a b value of 2 and an a value of 1/2. I'll leave that on the screen for you. And that is indeed, oh, we do have one more example, example number 4. But I'm thinking maybe that one might be best done in class, just because this has been a little bit of a long lesson. So I will see you guys very soon.